Today we'll be talking about properties and how they apply to solving equations. So first let's go through all the vocabulary that we have. We have a lot of different properties that we're going to go through, and then we'll review solving two-step equations, and then we're going to look at how we can apply these properties to our equations. All right, so first we have commutative property, and commutative property can be split up over addition and multiplication. So the basis of commutative property is that we can change the order. So we can change the order around an addition sign, or we can change the order around a multiplication sign. Order doesn't really matter. So I can do A plus B or B plus A. I can do A times B, or I can do B times A, and I'll get the same answer. I always like to think of commutative as like your commute to and from school. You generally follow the same path whether you're coming to school or going home, just in reverse order. So commutative, think of your commute. Associative property, again, that can be split up over addition or multiplication. Associative property talks about how we group things together. So we can move grouping around an addition sign, or we can move grouping around multiplication signs. So it doesn't matter if I group B and C together or I group A and B together. I'm going to get the same answer because it's all addition all the way through. Same with multiplication. Doesn't matter who we group together, we'll get the same answer. I like to think of associative property as thinking about who you associate with during the day at school. If you think about your lunch periods, you may have different lunch periods between your orange and white days. So who you associate with during orange day lunch may be different than who you associate with on white day lunches. And think of that in terms of who you sit with. What group do you sit with on orange days versus what group do you sit with on white days? You guys are all still friends, but you may not be able to sit with the same people each day. Identity property, again, also split over addition and multiplication. Identity property of addition says that any number plus 0 equals that number. And the identity property of multiplication says that any number times 1 equals that number. So we're really just looking to see whatever we start with is what we end with. So if you think about your own personal identity, you don't change. Who you are from the day you're born to the day you die, you're the same person. You may change your looks, but inside, you're still the same person. So you never change. Inverse. So then again, inverse we can do over addition or multiplication. Sometimes we'll see this as the additive inverse, and what that means is any number plus its opposite will equal 0. So a positive number plus the negative version of that same number will always equal 0. And the multiplicative inverse is any number times its reciprocal equals 1. So in this case, it's not really an opposite because we think of opposite in terms of signs. This is that reciprocal. Reciprocal is where we flip the fraction over. So if I have a number, if I want to make that a fraction, I can put it over 1. Well, then I can flip it over and I get 1 over that number. Multiply those two together, it'll always equal 1. And then we have our distributive property. A distributive property is a number on the outside of a grouping symbol being multiplied to an addition or subtraction expression inside that grouping symbol. Right? And distributing just means that we're handing something out. So I'm going to take the A, I'm going to give it to the B, I'm going to take my A, I'm going to give it to the C. Here I took my A, I gave it to the B, I took my A, and I give it to the C. Then we have the multiplicative property of 0. And that just states that any number times 0 will equal 0. And that's a pretty easy one. All right, so now let's go to the next page. These are all of our properties of equality. The first 3 are ones that we don't necessarily talk about, but it just helps explain how numbers work. So reflexive is a number that's equal to itself. Think of your reflection in the mirror. When you look in the mirror, you see yourself. That's the reflexive. Think of that equal sign as your mirror. Symmetric says that the order of equality doesn't matter. So I can say A plus B equals C. Well, that's the same as C equals A plus B. I could draw a line through here, fold it over that line, and my C's would match up, and then my A plus B's would match up. Transitive. Two numbers equal to the same number are equal to each other. I like to think of transitive as cutting out the middleman. So here's what I sometimes do when I'm looking at these. So if I've got A equals B, and then I've got B equals C, I can take those, okay, and I can kind of do that overlap. So A equals B, B equals C. We can cut out that middleman, and we're just left with A equals C. So that's what we're really looking at here. With that transitive property, we can cut out the middleman. So I can overlap my two B's, cut out the middleman, I'm left with A equals C. All right, substitution. This is where we deal with these next ones a lot when we're solving equations. And we've talked about the actual idea of substitution already. It's a number that is equal to an expression, can replace the expression. So if x equals y, then y can be substituted for x in any expression. Addition of equality. So this one states that if you add something to one side, you must add the same to the other side to keep it equal. So if we have x equals y, then if I add z to both sides, then I'm going to have an equivalent expression or equivalent equation. They'll still be equal. Same thing with subtraction. If I subtract the same number from both sides, then my equation will remain equal. Same with multiplication. If I multiply the same number from both sides, then my equation will stay the same or equal. And then again with division. If I divide both sides by the same number, my equation will still be equal. All right, so those are all of our properties. So now let's take a kind of switch gears a little bit and let's practice or let's review how we solve two-step equations. So to solve an equation, we need to isolate the variable. Isolate means get that variable by itself. We do this by undoing the operations in the reverse order of GEMDAS. So the reverse order. So ordering for solving equations. We would then say SADMEG. So we want to undo any of our subtraction and addition first, then our division and multiplication, and then any exponents we have, and then any grouping symbols. All right, so let's see if we can apply that. So the first thing that we always do when we're solving an equation is we draw a line through the equal sign. It just helps give you kind of those two different sides. What we do to one side, we have to do to the other side. That refers us back to these properties of equality here. In order to keep that equation equal, we have to apply these properties of equality. All right, so first thing we want to do is undo any subtraction or addition. So I've got some addition, let's undo that. We undo that by using the inverse. So the inverse of adding 4 then is subtracting 4. You can subtract 4 from both sides. And we end up with 4/5 m is equal to 24. So now I have this expression left. These canceled out. 28 minus 4 gave me 24. All right, so now the next thing we need to do is undo this multiplication. I have 4/5 times m. All right, so we have to undo multiplication. Well, we do that by dividing. The only problem is I can't really divide by a fraction. So we have to use our inverse with the fraction. So the inverse of 4/5 then would be 5/4. So I'm going to multiply this side by 5/4. I'm going to multiply this side by 5/4. And remember, if you're in Desmos, you can easily do that. So you can do 24 times, and then you can put in your division symbol, and it'll give you the fraction spot. All right, so we do that. This fraction ends up canceling each other out, because remember, when we multiply reciprocals, it equals 1. So 1m is the same as just m. So we're left with m equals 30. 24 times 5/4 gives us 30. We're done. We've isolated our variable, we can circle our answer now. As soon as our variable is by itself, it means we're finished. Okay, so now let's come over here and try this one. All right, so I'm going to start by drawing my line. We're going to go through and we're going to work out in these orders. Now the problem is, normally we say, oh, let's undo our subtraction addition. Well, there it is up there. But we also have this grouping symbol that we have here. So we kind of have to deal with splitting out that grouping symbol first. So this up here is part of, it's grouped together, and we deal with the stuff that's grouped together last. So we're going to jump over to trying to undo any division and multiplication. So I've got division. That's how I'm going to break out that grouping. So I'm going to undo my division by multiply. So since it's divided by 3, I'm going to multiply both sides by 3. So this is using that multiplication of equality property. Right? When I do that, these 3's right here will cancel out. And then we're left with -4 is equal to x minus 7. All right, now I can jump back to here because now I don't have anything grouped together anymore. So now I can undo that subtraction by adding. So I'm going to add 7, add 7. When I do that, these cancel each other out because they're inverses, they make 0. So my x is going to come down, -4 plus 7 gives me 3. So we end up with 3 is equal to x. Okay, I want you to try the next 4 problems on your own. Go ahead, pause the video now. Okay, welcome back. When we come back to class, I will put up those answers and you can check how you did. All right, let's come over here and look at set builder notation. So set builder notation is just a fancy way that we write our answers in algebra. So set builder notation says that we need to use brackets, and then we take whatever variable that they happen to be using in the expression or in the equation. And we're going to read this statement as the set of x's such that, so the set of x's such that x equals, and then whatever your answer is. So let's put our answers from example 1 in set builder. So if we go back to example 1, and our answer was m equals 30. Okay. So we're going to incorporate that m equals 30 into our set builder. So when we come down here, remember we have to use brackets. Instead of x, we're going to use m. So ours is going to say the set of m's such that m equals 30. So since m equals 30, right, we have our set builder notation. The set of, although there is a typo in this one, so let's see if we can fix that. Let's see. Let's see, yep, they have that already kind of grouped together. Those really should be m's. Those should be m's. So let's just retype that. So instead of this, we're going to retype that to make it what it should be. It should be brackets m. I'll put that line in. Oops. M equals 30. And then we'll close our brackets. All right. And then I'm just going to put that little line in there because we do need that. Red just so it matches up. There we go. So that's what it should be. Since our variable used was m, then we should use m in our thing. All right, the next one was 3 equals x. So when we go to put that in set builder, we say for the set of x's such that x equals, and in this case 3. We always want to write it as the variable equals the number when we put it in a set builder. So I know that this is flipped around, but we always write as the variable equals the number. All right, we didn't have these 2 examples, so now what I want you to do is I want you to try on your own Take the previous 4 answers that you did on the other try on your own and turn those into Set Builder. All right, pause your video now. Okay, when we come back to class, we'll put up those answers and we'll see how you did. All right, now we're going to justify the steps of this equation process by using our properties. So we're going to take a look at what they did to get from one step to the other, and we're going to state which property did they use. All right, so on this one here, we started with the equation 74 is equal to x plus 3v. All right, well, if we were to cover up, let's see, everything else, think about what would you do next? We have to isolate this variable. So we need to take this 8 and we need to move it to the other side. Well, how do we do that? Well, we have to subtract 8 from both sides. We have to undo it to positive 8, so we need its inverse, so we need a negative 8. So we're going to subtract 8. So here's how they show it here. They are showing that, let's see, by subtracting 8. Now when they show that subtracting 8, they show it kind of in line with the equation instead of underneath like we did before. So just a slight little difference in terms of how they show the work here. Okay, it's the same process, same thing. It's just a lot of places will show it more in line with the equation. So here we subtracted 8 from both sides. So what property is that? Right? Remember, if I do something to both sides, it's going to be an equality of equality. Since I subtracted 8 from both sides, it's subtraction property of equality. All right, let's look at the next step. So now, once we do that, okay, what did they do here? What changed from this step to this step? Well, if we notice, this minus 8 here that we had here, they moved it. They switched spots. These two here, these two terms, just switch spots. What property tells us that we can change the order? Remember, that's our commutative property. And in this case, it's of addition. Even though that was a subtraction sign, remember subtraction means adding a negative, it's always going to just be property of addition. Okay? All right, so now we've taken care of that. We've switched them just to get our like terms together. All right, now what are we doing next? All right, well, the next thing they did was they simplified. They did 74 minus 8 gave us 66. And then they said 8 minus 8 equals 0. So they substituted an answer in for a math problem. They substituted an answer in for a math problem. Although that's not what's here. This one they said the inverse property of addition. So we actually have two things going on. The 8 minus 8 is inverse because that equals 0. But we also have this one over here, which I'm going to add in as substitution. So we do also have substitution in here as well. Substitution. Okay. So there's two answers that can go here. So this part here, the 8 minus 8 equals 0, that's our inverse property of addition. The 74 minus 8 equals 66, that's our substitution. So we want to make sure that we take care of both. Okay? They're both properties there. All right, now, what happened next? We went from 0 plus 3v to just 3v. So what property is that? We could call it substitution because I replaced a math problem with an answer. But more specifically, I added something to 0 and I got itself. So we call that one the identity property of addition. We want to be as specific as we possibly can with our properties. All right, and then the next step, right, would be to divide. So now we're going to divide both sides by 3. So as soon as I do something to both sides, it's of equality. In this case, we divided, so it's division property of equality. All right, next, come down here, and we get an answer. All right, so when I divide a number by itself, I get 1. So remember what property that is? Okay, that's the inverse property of multiplication. Right? But then over here, I did a math problem. I got an answer. I substituted that math problem with that answer. So we're going to start with that inverse property of addition, and then we're going to add in that substitution property. Because both of them occurred. So we have that inverse property here that makes 1, and then we also have the substitution piece here. This turns into 22. We call that substitution. All right, and then that is it. All right, that brings us to our final answer. All right, so we really want to look at these step by step, and again, sometimes we have 2 different properties working at the same time. All right. So now I want you to try this one on your own. Go ahead and pause the video now. Okay. We'll review that when you come back from class. Okay, and that was it. That was it for our notes today. So when we come back from class, we'll go over each of those things. We'll get some more practice in, and I will see you next class.